After dealing with composite functions, it's good to go a bit into more depth and talk about more properties. So just to recap, the order of composite functions matters. So we've talked about how g of f of x is not necessarily the same of f of g of x. They are only the same in a special case. You always start with the innermost function and then work outwards. Now, what I want to discuss is this last point about the range, the domain and range. So the third sentence is a bit complicated, but I would recommend you try and pause and understand what happens. But basically, if I have all my domain of f, and those are all the values I'm allowed to put into f, and I compose them and I get f of x, and this whole process, I'm going to end up getting a range of f. Now, this range of f should be within the domain of g, or else I won't be able to compose the answers of f with g. Because remember, the answers of f of x become the input of g. So the output of f becomes the input of g. So by formal words, the range of f becomes the domain of g. So the range of f has to exist inside the domain of g, hence why the circle is smaller. Now, then we have the domain of g, which is going to give us the range of g, meaning that we have a big range of g, but because we are starting with the smaller input, not the bigger input, due to the fact that we're composing, we'll end up with a smaller range. So actually, the range of g of f of x is going to be the small kind of subset of the range of f. So the range of f is a subset of the domain of g. Since f of x is the input of g, it becomes the domain. Now we will go through some examples so that this is a bit clearer. So I would encourage you to pause and try this question. I'm going to go through both compositions. The point is just to show why they're not the same. So I have f of g of x and g of f of x. I would encourage you to pause and try composing them on your own first, and then we're going to talk about the domain. So I'm actually going to start with the second one, so g of f of x. Now if I go g of f of x, my input of g is going to be the function of f, which is root of x. And if I substitute root of x into g, I'm going to get root of x squared plus 3 root of x. The root and the square end up canceling each other out, so I have x plus 3x squared. You can try it out. Try square root of 4 squared, or square root of 2 squared, and you're going to end up with the same number. So this is my function now. If I want to talk about the domain, remember for the domain, you want to talk about all the values you're allowed to input in the function, or all the values you're not allowed to put into the function. That makes it easier. So remember with domain, try to assume that you're allowed to put all values in there. But what is the exception? Well, you know that square roots only take in positive number, meaning that I'm actually restricting my whole function. You are allowed to put any number in here, but you're not allowed to put any number in there. It means that my whole domain has to be 0 and above. So that x has to be bigger than or equal to 0. So I'm automatically restricting my domain. And as you can see, if you want to graph it, you can see that nothing will graph on the negative side, and everything only starts from 0 and beyond. So my domain is x bigger than or equal to 0, where x belongs to the real numbers. You can also use set notation, interval notation if you want to. So maybe start from 0, including 0, and then all the way to infinity. Now, what about the range? It's much easier to see the range from a graph. As you can see, it starts from a 0 and then goes all the way up. So the range, the y is bigger than or equal to 0, where y is in the real numbers. Another way to see it is if you actually substitute the smallest possible number in your range. You're going to get 0 plus 3 root of 0, which is equal to 0. So obviously with the smallest domain, you're going to get 0. And then you can test out more numbers. The higher the value you put in, the more your range increases. And so you're going to end up with just values increasing. So your range is going to be y bigger than or equal to 0. Now, it's different when you do the other composition on the other side. So f of g of x is going to be f of x squared plus 3x, which if I put inside my function f of x, I'm going to get this. Now, this does not simplify. Be careful. The square and the square root do not simplify because inside your root or your surd, you have a positive in there, and we don't simplify it if it's such. If it was a multiply, then yes, you can simplify, but you can't when there's a plus. I do have a video on surds if you want to go there and recap. Now, the domain, it's much easier to talk about the domain if you have the graph in there. If it's a non-calculator type of question, then you could actually solve the domain on your own using quadratic equations and so on. But that's something if you've done solving quadratics. So if you have done solving quadratics, we will talk about the domain the same way we did with the previous example, where if you look at this function, this composite function, you're not allowed to put anything inside here that is negative, meaning that x squared plus 3x has to be bigger than or equal to 0. And then you'd have to solve it. Okay, which is a more complex way, but if you want to go there, if you do have the techniques for quadratic solving, you can. So that's something to keep in mind in case you're faced in a non-calculator paper. If we don't, then we can look at the graph or the table. So I've graphed my function here. As you can notice, nothing happens here. All my input, if I'm scanning my domain, I'm scanning the x-axis, it starts all the way here and then stops there and then goes there again. And I could go to second and table. And table is above the button graph. And as you can see, with anything between 0 and 3, so only at precisely 3 do my values start. And at 0, this is where my values start. And you can try in the graph and see that this is -3 and this is 0. Meaning that my domain is all the values x less than or equal to -3 and x bigger than or equal to 0. Writing this in proper set notation, you would go, instead of writing the and, you'd write the union. You can use set intervals if you want to, so start from -infinity to 3 included, union 0 up until +infinity. So we're avoiding that middle section because all the values there, if I test it out, it's going to give me a negative value, which is allowed in x squared plus 3x, but it's not allowed in my composite function. So those are the value, and -3 and 0 are included because you can have a 0. Now what about the range? Again, the range is easier to see if you are scanning the graph from the lowest to the highest. Obviously with square roots, they're only a proper function if they're defined for a positive output or one output, so positive or negative. So in here we're specifying a positive, we're assuming positive outputs. And as you can see, the range starts from 0 and goes all the way up. You can see it here as well, so it starts from 0 and increases. Similarly here, it goes 0 and increases. So my range is y bigger than or equal to 0. Well, y belongs to the real numbers, and here as well we want to specify x belongs to the real numbers. So hopefully this was useful, and then you can take all of that we did into account and explain why the domain of each composite is not the same. It's because composite functions, the order matters, so the domain and range will not be the same. Depends on the function order.